Let us elaborate on each production technique, starting with open flow. Fluid flows to the bottom hole of the well because of the pressure difference between the bottom hole and the reservoir. If pressure of the fluid that fills the well up to the wellhead is lower than the reservoir pressure, the well will flow naturally. In other words, with these production techniques, oil and gas will flow up the well bore from the bottom hole to the wellhead thanks to the energy of the reservoir, hydrostatic head, and expanding gas. In reality, open flow caused by hydrostatic forces only happens on rare occasions. Mostly, open flow is caused by natural gas that is contained in reservoirs along with oil. In oil reservoirs, their bubble point pressure is equal to reservoir pressure. Gas serves two purposes. In reservoir, it forces oil out, and in production tubing, lifts it up to the surface. In some cases, gas does not come from solution, while oil is in the reservoirs. But as the oil goes out the wellbore, pressure falls down. Then they reach the bubble point, gas starts coming out of the solution and helps lifting the fluid up. This technique is the cheapest one, as it does not require additional energy that would lift the fluid up to the surface. Besides, it does not require special equipment, which is expensive and requires maintenance. Still, we need to mention the equipment installed on any well, including the free-flowing one, should be able to keep the required production regime and allow for technical operations necessary for environmental management and accident control. There are two types of such equipment: downhole and wellhead. Downhole lifting equipment includes production string, which is lowered into the wellbore down to the depth of the upper perforations. Through this string of pipes, oil and gas flow up to the wellhead. The lower part of the lifting system is equipped with a centering funnel. Please note that the same amount of gas may be sufficient for open flow in one well, but insufficient for another well. For example, 150 mm well may flow, but 200 mm well will not. The mixture of oil and gas moving out the wellbore is somewhat similar to a layer cake with layers of oil and gas. And the bigger the production tube in diameter, the more gas is required to lift oil. There have been cases that large diameter wells, 150 to 300 mm, drilled into high-pressure, high-capacity reservoir showed great production rates, but the open flow in such wells did not last long. There are wells that do not flow at all, although reservoir pressure is high. We can initiate free flow in such wells by installing a lesser diameter production string. Engineers select production string diameter empirically based on expected flow rates, reservoir pressure, well depth, and operating conditions. Production string serves many more purposes than lifting oil and gas. It is also used for well control, well service, well stimulation operations, pressure control, solid control, elimination of asphalt, resin, and paraffin deposits, prevention of pipe corrosion and erosion, well killing before workover operations. Open flow requires that the wellhead should be sealed off, tubing casing annulus should be isolated, production stream should be directed to central production facility. If necessary, we also should be able to close such a well completely. This is ensured by installing special surface equipment, tubing head and Christmas tree with a manifold on the wellhead of a free-flowing well. Wellhead equipment includes casing head and Christmas tree. Casing head connects upper section of the casing string, pegs of the annular space, and supports the Christmas tree assembly. As for the Christmas tree assembly, it serves the following purposes: pegs of the wellhead direct the Well fluid into the flow line controls well operation regime. Christmas tree assembly consists of various flange teeth, cross teeth and valves that are locked together with lock pins. It includes two elements, tubing head and Christmas tree. Tubing head attach flow string or two flow strings. Pegs are the annular space between the production casing and the flow string and allows for technical procedures such as well completion, well clean out, removal of paraffin deposited on flow strings, sand removal, well workover, etc. Typically, tubing head is cross-T with two side outlets and the tube hanger. The side outlets provide access into the annular space to inject water or killing fluid, to add hydride formation or corrosion inhibitors, to withdraw gas, and to attach a manometer when we need to measure the annular pressure. Tube hanger is installed directly on top of the tubing head. The upper part of the Christmas tree assembly is called Christmas tree itself. The Christmas tree directs well fluid from the production string into the flow lines, controls liquid and gas flow through valves and chokes, provides access for various well survey and intervention operations, and when necessary, well killing. The Christmas tree is a set of valves connected with teeth. Typically, valves are installed in couples, master valves and wing valves. In the upper part of the tree, the swap valve is installed, which is used for well interventions. In such cases, a lubricator is installed on top and the required tool, a paraffin scraper for example, is lowered into the well bore on a wire. Thanks to the lubricator, the well remains leak-proof and can operate while the tool is working. Manometers are installed on the Christmas tree for production control purposes. Different types of Christmas trees have different characteristics, such as design, operating pressure, flow diameter, number of flow strings attached, types of valves, and chokes. If we want our well flowing steadily for a long period of time, we need to control reservoir energy by changing the volume of oil coming out of the well, or the so-called flow rate. To control the flow rate, a replaceable choke is connected to a side outlet. Such chokes are made of wear-proof material and orifice has a specific diameter which will determine how much oil will be flowing out of the well. The diameter may vary from 3 to 15 millimeters or above 15. Sometimes bottom hole chokes are used, which can be faster placed and adjusted. Such chokes are installed on flow strings at any depth, supported by packers. Free flow or natural flow is typically used at early stages of field development. Yet, when it comes to gas wells, all of them are free flowing. Gas comes up to the surface thanks to the reservoir pressure.